Any questions here? Okay, so in that case, let's go back for a second. I would like us to just look at any of these step functions. So use the graph of the postage function for each of the following limits. So as x approaches 1 from the left, how much will I pay for postage? 1 from the left.
$1.
$1. Awesome. 1 from the right.
121.
121. Awesome. And 1 from either side.
Does not exist.
Does not exist. The limit from the left is 1. The limit from the right is 1.21. But from the limit from either side, I don't have an answer. If I don't have an answer, it's D and E. Okay. Let's also look at this one with the cost. The limit from the left of 0.6. The limit from the left of 0.6.
4.
4. The limit from the right of 0.6.
4.5.
Correct. The limit from either side of 0.6.
Not connected. Does not exist?
Does not exist indeed. Perfect. Moving on, 1.2. In 1.2, we're going to look at algebraic limits. What did we do here? We looked at graphs. We created the table, and we determined the limits. This time, we're not going to graph the function. We're just going to algebraically determine the limit. So there are a certain number of limit rules or properties. So we have to have some assumptions here, and we assume that the limit of f of x as x approaches a from either side exists, is a number. We're going to denote it by L, because we're going to look at general situation, and then we apply this. And then the limit of g of x as x approaches a is, let's say, m. So this is our assumption, that the limit of f of x as x approaches a is a number, and the limit of g of x as x approaches a is a different number, or the same, it doesn't matter. So now, here's our first property. Actually, I'm going to make it together. 2 properties, but in one. The limit of f of x plus g of x as x approaches a from either side. A wild guess. What do you think this will equal to? And no, we are not distributing the limit operator here. But the limit of a sum or a difference is the sum of the limits.
Positive number.
Is the sum of the limits or
M plus 6.
or the difference.
L plus M.
Exactly. Exactly. Excellent. So it's, if this is L and this is M, plus or minus L. So in short, we should remember like this. The limit of a sum is the sum of the limits if they exist. If they exist. If they don't exist, I cannot use this property. Okay, that's one rule. Second rule, the limit as x approaches a from f of x multiplied by g of x. What do you think this is?
I have a quick question.
Yes, please.
What did the L and M stand for again?
Any number. If you like, if you don't like L, put 2. If you don't like M, put 4. Any number.
Thank you.
As long as They exist, as long as it's not infinities. So then this will be 2 plus 4 or 2 minus 4. Any number, a generic number. Assume that they exist, the limits exist. Okay, what about this one? What do you think? Wild guess.
L times M.
Yes. So this will be the limit of f of x as x approaches a times the limit of g of x as x approaches a, and indeed it will be L times m. If it's 2 and 4, it's 2 times 4. How do we remember this? The limit of a product is the product of the limits as long as they exist. 3. What do you think is next? What's next? Of course, f of x over g of x. What do you think this will equal to? Wild guess.
L over M.
The limit of f of x as x approaches a over the limit of g of x as x approaches a, L divided by m with a very big if. If what?
And M doesn't equal 0.
Correct. As long as limit of g of x as x approaches a does not equal 0. And of course, m does not equal 0. Because this is a ratio, denominator cannot be 0. Okay, number 4. The limit of a constant, any number you want, times f of x as x approaches a. So let me explain this situation here. So this, as long as it's a factor, the factor can go in front. So this is c times the limit of f of x as x approaches a. And what will this equal to? What do you think?
C times L.
Yes, c times l. Any questions so far?
Could you go over what C is again?
Say it again.
Could you go over what C is again?
Any number. Any number. A constant. Any number you want. 5, 10, negative 100. Good. One more here. So if we have the limit of, let's say, f of x to power n as x approaches a, these are two operators under certain conditions. I'm going to put the condition in parentheses and I'll explain it. Continuity. Under continuity. We don't know what that means yet, but I have to mention it because it doesn't always happen, right? We are allowed to swap. As you see, this operator tells us to raise the function to the nth power. When we're done, this operator says, okay, where's the tendency of this function when x approaches a? Operator number 1, operator number 2. I'm going to swap them. Operator number 1 and operator number 2. So this was 1, it became 2. This was 2, it became 1. But only if we're talking about continuous functions, which we haven't defined yet. So what will this equal to then?
M is equals L.
So this is L raised to the nth power. Okay?
Equals to L to
I'm sorry? Say it again.
No, we're gonna compare the two or only one.
This one is just one function.
Oh,
It doesn't matter what function. If it's a product or a sum, it's a function in general. It doesn't matter. We don't have to write it for G. So, of course, there are certain conditions, and N, you know, if N is negative, then L cannot be 0. So, but this is a general case. And last one, I promise. The limit as x approaches a, but this time it's the same idea, but the nth root of f of x. Still under continuity, operator 2, operator 1. I'm going to swap them. What will this equal to?
oh, the square root then.
Yes, the nth root of L. Yes, exactly. Awesome. Very good. I would like us to look at few situations. And I am going to open, let you choose on page 124. 124. Enter. Okay. So algebraically now we want to know graphs. Yes, we can look at some graphs here and determine whether each of the functions shown is continuous, but we haven't talked about continuity yet. I want us to investigate anything you'd like from 9 through 46. We're not going to be able to finish every model or every type, but we want to make headway. So let's start simple. Let's start with polynomials. 9 through 16. Polynomial functions.
13.
So this is the first category. You said 13. Very good. So the limit as x approaches 3 from either side, x squared minus 4x plus 7. Awesome pick. Great job. Okay. So notice that I have to have the polynomial in parentheses. If you omit parentheses, it only says that you're calculating the limit as x approaches 3 of x squared. If you put parentheses, then it means they are calculating the limit of this, the entire function, the entire polynomial. So please understand, parentheses are mandatory here. So for polynomial functions, so the limit of a function that is polynomial when x approaches a is the simplest possible situation. When this is a polynomial. What does it mean? Plug it in. Because there is never a problem with polynomial functions. They're friendly, smooth functions. Just plug it in and give me the answer. However, you could say, no, you already told me that when x approaches 3, x cannot equal 3. Now you're contradicting yourself. You're telling me to plug in 3 and get a number. True. Every time we determine a limit, we will start by plugging it in. Always. In this case, it happens that I get a number. If I get indeterminate situations, I'll explain what I mean in a moment. Then it's a different story. We'll discuss it. But if it's a polynomial function, 9 minus 12 is negative 3. Negative 3 plus 7 is 4. Done. These are the easiest possible functions to work with. So the limit as x approaches 3, 9 minus 12 is negative 3. Negative 3 plus 7 is 4. What does this say? That this polynomial function gets closer and closer to 4 when x gets closer and closer to 3 from either side. Okay, so polynomials, the easiest thing, we can move on. Let's talk about rational functions. So let's choose a rational function now, either those or here. 19 through. These are rational, but they are not, they are a combination, rational with radical. Okay, so we have time for one more. Let's choose one, any of a rational function that you want to work on. Any preference, or I will choose?
23.
Which one?
23.
23 it is. So we have limit as x approaches -3 from 2x squared minus x minus 21 over 9 minus x squared. Very good. Before we even look at this, 0 divided by a number is always d/e. But sometimes we will not write d/e. What does this mean? So there is no hope. No hope. And no hope for something like this. Oh! I'm rushing because I look at the clock and I don't want to hold you over. Okay, so when there is a number not 0, not 0, this is not 0, any number you want divided by 0, you can say this is undefined, I agree, for the function, and the limit has no hope. So the limit of something like this has no hope. But those are three options: infinity, negative infinity, or d/e. As we know, all of them are d/e, but we don't write d/e if we have this. We don't write d/e if we have this. We write d/e when we have this. However, 0 over 0 has hope for the limit. There is hope. I'm not saying that the limit exists. I'm saying it's possible. There is hope. Okay, so as I mentioned, every time we are asked to find the limit, we have to plug it in. Can anyone plug it in at the top and tell us what we get? And can anyone give us what we get when we plug it in the denominator? So 9 times 2 is 18. 3 minus 21.
I think the top is 0.
0 over 0. Ah, there is hope. There is hope. Okay, so I'm going to circle that and continue here because I have stuff in the middle. So then limit as x approaches -3. First of all, I don't like the denominator because it's not in descending order and it has a negative leading coefficient. So that's the first thing I do. In a polynomial, when I plug in -3 and I do get 0, x, when I say to you x approaches -3, I can also say x plus 3 approaches 0 is the same thing. So x plus 3 must be a factor. So when in a polynomial we plug in -3 and we get 0, x plus 3 must be a factor. If I plug in 10 and I get 0, x minus 10 will be a factor. Can anyone give us the other factor that makes 2x squared minus x minus 21? And it has to be 2x minus 7, right? Let's check. 2x squared, 6 minus 7, -1, and -21. So now I continue with limit as x approaches -3. Of course, I will factor. Can anyone give us the factor form for the denominator? Anyone?
X plus 3, X minus 3.
I know exactly what creates the problem. Can anyone tell us which factor is the problem, and if I can get rid of it, I have hope?
You can get rid of X plus 3.
Exactly, that was my problem. And now let's plug it in. Negative 6 minus 7, negative 13. Negative 3 minus 3, negative 6. Positive 6. This is it.